Hello gentlemen, welcome to my channel. Hello gentlemen, welcome to my channel. Today in this video we'll be talking about the derivation of equation for those lines which do not pass through the line. In the past two videos we have already spoken about the lines which pass through the origin, but it is not necessary that all the lines will be passing through the origin. Some lines will be above the x-axis and some would be below the x-axis, cutting the y-axis at the respective places. So we'll have to derive the equation for this kind of lines, which would be the generalized formula for the any line lying in the graph. We'll be using the formula of a right angle triangle, that is the perpendicular upon the base would be equal to some constant value. Let's say it is a. So P is equal to a times the B. So we'll be using this formula. So let's take this line for which we are going to derive the formula. And for this, we have to take the help of a parallel line which passes through the origin. Say this one. And as we said, we'll be using the formula for the present line passing through the origin, for which we already know the formula. And for that, we have to take some other coordinates. Let's say, for example, one point plotted and specified with the blue color, which is at height from the x-axis, which is shown in the orange color. And the length of the x-axis is OA, that is 7. And the point where the vertical line from A cuts the line passing through the origin is B. And the point cut by the arbitrary line parallel to this line passing through the origin at the y-axis is C. And the value of the total height from the point chosen from the base is OD, which is 10. And the point where the vertical line from A touches the point is at E. So the y in this case of the arbitrary line passing through the point C, making an angle arbitrarily, is the value of the y is equal to AE, which would be equal to AB plus BE, and that is equal to, first let's try to understand what AB is. AB is equal to 4, and that by the rule of the right angle triangle would be equal to coefficient of the x 4 by 7, because 4 is the y value at AB and 7 is the x value at OA. So 4 by 7 is the coefficient of the x for the triangle. For AB, that would be multiplied to the base, that is the x coordinate, and BE is equal to OC, because both the lines are parallel to each other. Now OC is the constant which is equal to the point through which the arbitrary line cuts the y-axis. That means even if the x has not been taken any value, for x to be 0, y would be having still some value, that is equal to 4/7 into x plus c is the constant. That is equal to a is the coefficient of the variable x, a into x plus c. So this is the generalized formula for any line in the graph. Y is equal to ax plus c, where a is the coefficient of the x according to the angle that it makes to the base, the x-axis, the horizontal axis. A is equal to coefficient of x according to the angle of line from x-axis. So the generalized formula is this. So in this case, we can write for the line y is equal to ax plus c. For this particular line, a is equal to 4/7. So we can write y to be equal to 4/7 into x plus c, where c is equal to, it is 6. So the formula for the line is 4/7 x plus 6, and here it would be equal to y is equal to only 4/7 into x. C is 0 because the line passes to 0. So this way the formula for the lines can be derived. The equation for the line that we have derived in the graph is also called as the first order equation. And there are also graphs which are termed by the highest exponent that the variable has. Like for the second order equation, the exponent being the highest is 2, where the equation has the form of being written as ax squared plus bx plus c. So the first term being the ax squared, the exponent of the variable is 2. So that is why it is called as the second order equation. And it goes on increasing as the exponent of the variable also increases. So it is the nth order equation where the highest exponent of the variable is n. Now it is also called as the linear equation. The word linear comes from the word line. The change in the x and the y is in line. The next video is going to be a real interesting one. Characteristics equations have are according to their order of the equation. Like for a straight line, the line being expressed in terms of the first order equation, root of the first order equation is only 1. Likewise, for the second order equation, the roots will be 2 in numbers. And for the third order equation, the number of roots will be 3. That means the first order equation being a straight line will touch the x-axis only at one point, and the second order equation being bent only once will touch the x-axis at 2 points. But it might so happen that the curve will not touch the x-axis at all. That means it won't have the roots at all. And for the third order equation, generally it has the 3 number of roots in maximum. So this is all about in this video. The next video is going to be a real interesting one. Subscribe to my channel if you want to learn about the other interesting topics and the interesting facts about a curve or any article in the mathematics topic. And do share this video among your friends so that they can also be benefited out of this. Don't forget to put your comments and also the suggestions that you might like to hear from me so that I can make videos according to your suggestions and requests. Thanks for watching this video and see you soon in the next video. Till then, take care of yourselves. Bye bye.